place where it's almost an introduction. It's almost an introduction to third semester calculus. In third semester calculus, you end up with not just an integral, but you end up with a double integral, or a triple integral, or an n number of integrals as you go through it. And I'll make a few connections now, but if you stick with me for Calc 1, 2, and 3, you'll see sort of a continuous thread going through all of it, where it's all sort of interconnected. Area between curves. Let's start here with a picture. We know what we're talking about. We are specifically referring to this area of interest. Now, as we're looking at this, as I integrate f of x from a to b, that's going to give me the area, right? Technically, it gives me the area on to infinity. We're saying now let's stop. Normally we stop at x or at y equals 0. We'll talk about that in a second and make a connection there. But what we want to do is we want to find the area between these two curves. We're going to do something that's very, very obvious, and I'm actually going to find the area under f and subtract off the area under G. Okay? It's that simple. So the overall area a good teacher, I break it down into the delta x, and then delta x becomes, goes to 0 and the whole thing, but you get the idea. Let me get to that practice. As far as the subtraction goes, it's always, when f is a function of x, and not sideways, but f is a function of x, it's always going to be the top function minus the bottom function. Now, if we're looking for strictly area, it's possible that the two cross each other. We'll have to find that point of intersection and swap it out. We'll get to that. Okay. I'd like to find g of x. Would you please take a moment and graph these two functions on the same graph?
There you go. I meant square root.
We're going to be doing quite a bit of graphing this time and next time.
that's sweet.
It's just super small.
So here we have the area between two curves.
It's just super small.
What are the things we're going to have to calculate in this case? What are the boundaries of the integral? In other words, what is x going from and to? Now we could eye it, but mathematicians don't like to eye it. Engineers do. Engineers do. So let's figure this out precisely. I'm going to set x squared equal to root x. That's going to be where they intersect, right? Mm-hmm. These are actually going to be our boundaries of integration. We're cool with what I just did, right?
Yeah.
So even to get the boundaries of integration, we had to work for it. Which function is on top? The green in this case, right? The g of x? So in this case, g of x is on top. So if I go back to this, that's actually my f of x. So they're actually switched in this case. But don't let that throw you. They're just generic functions. So to find the area of interest between the two. Now, there is, of course, more area between the two as they cross, but we just mean enclosed like this. Then we're going to do the integral. I'm going to take a minute and let you work that out.
Does it matter whether you put the function in?
Yes, it does. It has to be the one on top minus the one on the bottom. That's why I drew the picture. It'll really matter in this next example, actually. It should be a relatively easy integral after what I put you through. This is a definite integral. Don't forget your Jolan. No, Jor-El.
Sure.
What's that?
We get that in practice all the time.
Well, there are unusual names of J at the beginning. Nice thing about 0 to 1 is you don't have to worry about the exponents. The 0's gone, but the 1 just leaves it 2/3 minus 1/3.
No, you got.
That's kind of amazing, I think. The area between these two weird curves is exactly 1/3. I mean, they come up with such a normal number, you know? Any questions? You get the general idea?
So this is for both answers, right? Oh, wait.
That's when I put into 0. That's when I put into 1. But that's just it.
graph these two functions from 0 to pi over 2?
This one.
Oh, this is pi over 4 and pi over 2, right?
Well, come on, take a look at your notes. That's not to be rich. Let's see your graph. I know you're not just sitting there waiting for me to.
Pi over 2, pi, 3 pi over 2, and then 2 pi. So this would be, I guess it's right here then?
What's the point? Whether it's intersect. It's gotta be the point where they intersect. So
there's like 2 separate areas?
sorry about that.
I don't know.
This point and this point.
0 to pi over 2.
What?
It's where it's the first peak of sine, right?
Uh-huh. Where cosine is 0.
Like that, right?
Yeah.
Now notice on part of this, one function is on top, and for the other part, the other function is on top. I need to find where these two intersect. Meaning where sine equals cosine. They obviously do, actually an infinite number of times. How would you solve a problem like this? What would you do? Like Gus?
Yeah.
We know you know what you're doing.
Divide by cosine.
Good job. Divide by cosine, get tangent x. Well done. Can I cancel out the x's and the s's? Can I do that?
Just the s's.
Yeah, come on. So where does tangent equal 1? At pi over 4. In fact, that is between 0 and pi over 2,
That's not what you
right?
said?
Yeah.
Now here's what I will not allow. Hey, it looks like it's in the middle. Must be pi over 4.
Damn it.
Okay, that's a very good guess, but I want to see the work on how you got that. We're going to have to actually break this up into area 1 and area 2. Because there's a different function on top. Now, I've done all the setup for you. I want you guys to piece together with a neighbor exactly what the heck just happened. Why did I even need to do this?
We got pi over 4, we got pi over 2. So he's adding... He's solving for one function. And then he's adding it to the other one. So yeah, he just broke it up.
Yeah, it's fine.
Larger's on the top, subtracting it.
Yeah.
Larger's on top, subtracting it. And then he's adding the two values together to get the total volume of area 1 and area 2. Yes.
depends which one's on top.
I miss math. So nice and relaxing.
Now, in reality, the two integrals are going to generate the exact same area. So there's what we call symmetries involved. Now, we can't prove that yet, so here's what you're going to do. You're going to buddy up with someone. One of you are going to do this integral, the other one's going to do this integral. So please take a moment and do one of the two integrals with a neighbor.